Oops. So for number 2, we have to solve the system. In order to do that, we need to eliminate a variable. I'm going to eliminate our x's. Alright, so let's just eliminate these two first, and I'll multiply the bottom one by a -1. And I end up with the first one I'll copy. And the second one I'll distribute that -1 to everything over here. So minus 1x, minus y, minus z. And then on the other side too, we have minus 2. And the x's are gone like we want. This becomes a 3y. This becomes a 4z. I don't know where that came from. And here I have a 7. Now we'll eliminate the x's from here also. And I could do that by multiplying this middle one by -2. So I end up with -2x minus 2y minus 2z is equal to -4. And I'll just copy this one. And I end up with the x's are gone like we want. I get a positive y plus z is equal to 3. Right, now we need to take those two equations with just the y and z now and eliminate something else. So both of them look pretty easy. I'll eliminate the y's in this case by multiplying this by -3. And I end up with minus 3y minus 3z. Minus 3z is equal to -9. And copying that one underneath, I have positive 3y. 4z is equal to 7. And now our y's are gone, and I'm left with z is equal to -2. And look, I already see my answer there. So there's our answer. Now, if you don't see that, if you don't see that, then we can always start back substituting, and I can plug in, for example, z equals -2 back into one of our last bracketed equations. So I can get y by just plugging it in. And getting y would be equal to 5, which is not 6. And so on. And you can do this by plugging both of these in to an original equation and getting your x. But again, we already have the answer, so we'll stop there.